Good evening, everyone. Last time we have covered up to the introduction to the heat treatment, that why heat treatment is being done. This time we are covering the annealing part. So annealing is a heat treatment process wherein that why it is required. It is required so that we can carry out the further working of the material, that to increase ductility and reduce the hardness to make it more workable, right? So it requires the material above its recrystallization temperature for a set amount of time before cooling, and the cooling rate depends upon the type of metal being annealed. That for example the steel, so they can be air cooled, whereas the alloys like copper, silver, and other materials and brass are air cooled or quickly quenched in the water. Now, why that how and what are the various stages of annealing? So we have covered this part also, that there are three stages. One is recovery, one is recrystallization, and then grain growth. Recovery may the linear imperfections. Now coming to the point that how annealing it improves the workability of a material, that it moves the dislocations, and the dislocations then add up and then they diminish in the number, and then the various grains, the new strain free grains are formed, and then those new grains continue to grow, and then their size grows. So in this way annealing works. So when is annealing required and why is it important, we have covered this thing, that that the effect of work hardening, that internal stresses, so they are being relieved in this case by help of annealing. That if the material become too hard, it can make working impossible, or it can result in cracking. So by help of annealing, those stresses are being removed, and it can also be useful in case of weld. That in case of welding, we then quench that part by help of water. So it creates the internal stresses in that part, and then if I have to actually do further working of that part, it becomes difficult, so annealing has to be done. And I have said that annealing is not only useful in case of steel, but in case of copper, brass, and other material like aluminium also. So can annealing be used in alloys? Yes, it can be used at temperature of between 300 to 410 degrees Celsius, and heating time ranging from zero point 0.5 to 3 hours. Advantages we have covered, that it improves the workability, and then increases the machinability, and then increasing toughness. Disadvantage is that in some cases we have to cool the material in the furnace itself, so then it can be a costly affair, and then it can be a time consuming effect if it is cooled in furnace. So those things. So material with high temperature requirement can take sufficient time to cool sufficiently. Applications that I have covered, that key where it can be. Now coming to the process or subcritical annealing. What is a process annealing? So this is the diagram of the this thing. So this is the pointer. So if I have to do the process annealing, so I have to cool it below the critical temperature. And then if I have to actually do full annealing, then this temperature line, that is above the A2 here, and then this line. And if I have to do the normalization process, then from here and then from here, so from here and then above this line, so this is the normalization process. So we have covered three things. One is the full annealing, wherein the material is being cooled in the furnace itself. Normalization में furnace में cooling नहीं होता, that we cool it in the air itself. So from here to here it is the temperature range. And the recrystallization or stress relief में from here to here the temperature are being shown. So now the process annealing. So it is used to improve the cold working properties of low carbon steels. It heats the steel to a temperature below the lower critical temperature, as I have mentioned, and is often known as subcritical annealing. And then the steel is cooled to room temperature in still air. So temperature range of the AC one is about 700 degrees Celsius. And this process can be used to temper martensite. Temper का मतलब that if there is very hardness, that very high hardness, so then it can create the cracks, and it will make the working very difficult. So to relieve those stresses and to make that thing, we heat it up at a lower temperatures. So that is known as tempering. And the carbides in ferrite, so they are being created in the spheroidal form. It is because of the surface tension, that it is because of the same phenomenon, that the water vapors are being spherical in nature. So this is the process annealing. And then the full annealing may we have covered that here a uniform and stable microstructure is being created because we heat it above the austenitic temperature and held for sufficient time to fully form austenite, and then allowed to cool it very slowly, so that equilibrium microstructure is obtained. That is, austenite formed is not allowed to form into martensite or bainite, but into perlite and ferrite, that is mentioned here, perlite and ferrite. So these steels are being furnace cooled, and it results in a more ductile material, but a lower yield strength and a lower tensile strength, right? Now the process of normalization, that here the steel is heated above the upper critical temperature, and then heating the steel just above its upper critical temperature, which create austenite, and then it is cooled in the air itself, so as to relieve the internal stresses. This is the process annealing, which I have covered, that subcritical annealing and then other things. Now hardening. Hardening में what is the thing, right? So hardening में we heat the steel above the critical temperature, right? And then hold it there enough for the molecular transformation to occur. So मैं ऐसे करता हूँ कि मैं critical temperature से above को उसको heat करता हूँ, and then hold it for the molecular transformation, that whatever that जो उसके अंदर austenitic वगैरह transformation होनी है उसको मैं occur करने देता हूँ, and then I cool it very rapidly by help of either water or brine solution. Brine solution is just actually water plus में any salt solution, so that कि उसको that the cooling rate, because cooling rate plays a very vital role here. And if the sufficient cooling rate is there, then we can create the martensite, because Martensite is a hard material, or the hard constituent in this thing. So if martensite occurs, and then if that austenite converts into martensite, so then the hardness would be very high. Then metal tempering में we reheat the steel which is very hard, and which can show the and hard means brittleness also. So we reheat the steel at a low temperature so that spheroidization of the carbides is being created, is being possible, and then it relieves the stresses induced by the quenching. So this is the tempering. So tempering is generally followed by the hardening process. That if a hardening is being done, so after that we do the tempering process, right? So this is, we have covered the annealing part. Annealing may the process, the various types of annealing, and then normalization, and then hardening, right? So goodbye, bye.